Hi guys, we are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science, and today we are here with you to continue on thermochemistry, also called energy changes. In this lecture, we are going to look at the standard enthalpy of hydration. Now, what do we mean by that? It is very simple. When you add solute or salt in water, there is an interaction between the salt and the water. This generates energy. The amount of energy generated during the process is what we call the standard enthalpy of hydration. And so we are going to take our time to explain this on a detailed level. Now, let's look here. When you add sodium chloride to water, basically what happens is that the water quickly comes to surround the salt. When you add salt to water or sodium chloride to water, the water quickly comes to surround the salt. Now, why is that happening? It's a very simple thing. Because the water itself contains ions. The water itself contains ions, that is the positive side and the negative side. And so let's look here. So I have the sodium chloride. And it has what we call the positive side, which is the sodium, and also has the negative side, which is with the chloride. Now, when you add it to water, the water is also having its positive and negative side. Okay, now the positive side of the water is this, and then we have the negative side of the water, that is the OH minus. So when you add it, when you add sodium chloride to water, quickly some number of water molecules quickly come to surround it. It comes to surround it. Now I have 6 water molecules surrounding 1 sodium chloride, and so there's what we call attraction and repulsion at the same time happening. Because the water also contains positive and negative, the cation also contains positive and negative. There's what we call attraction and repulsion at the same time. Now, the negative side of the water is attracting the positive side of the salt. So we have what we call this particular one. This is attracting the OH of the water. This is attracting the OH of the water. So the water molecules, which is the negative side of the water molecules, are attracting the positive side of the salt. And then again at the same time too, the negative side of the water are also attracting the negative side of the salt, which is this. Which is this. So which is this one. Which is this. So the negative side of the water, which is still the OH minus, or have you gotten that? Is still repelling. So there is what we call attraction and repulsion at the same time happening within it. Now, but we all know that for the sodium chloride are also held by a bond. We all know that the sodium chloride are also held by a bond. They are also held by a bond. Now, and that bond is also called lattice energy. The lattice energy. So there is a competition, or there is a fight between the water attracting the ions of it, and then the salt itself. The ions of the salt are also being held together, in order to prevent the breaking. And this is what we call the lattice energy. So there's a lattice energy, holding the ions of the salt together, and then there is what we call water also attracting the ions, trying to break them or separate them. And so there is what we call a fight or a competition between the 6 water molecules against 1 sodium chloride, against 1 mole of sodium chloride. And so basically that is what happens. And this attraction and repulsion of water molecules with the ions of the ionic compound is what we call the hydration energy. So while this is happening, the attraction is liberating energy. The attraction of the water molecules with the positive side of the ion is liberating energy, whilst the repulsion of the negative side of the water with the negative side of this one is also decreasing the energy. This liberation and decreasing is still what we call the hydration energy, because it is the water that is attracting and repelling. And so there is 2 hydration energies taking place here. There is what we call 2 hydration energies taking place here, and the first hydration energy can be accounted for this. So here we can say that here the total hydration energy. So here the total standard enthalpy of hydration, that takes place when you pour sodium chloride in water. Have you gotten that? Is 1, the hydration energy taking place when water surrounds the ion, that is when water surrounds this, that is the hydration energy taking place when what we call water surrounds the cation, plus another hydration energy when another hydration energy is the standard when the water also surrounds the negative, and but this is libration, otherwise exothermic. Okay, this is libration, and this is what we call absorption. Okay, because why? This is a repulsion, this is an attraction, this is generated through attraction of the negative side of the water and then the positive side of the ionic compound. So this is an attraction, okay, causing a liberation of energy, and this is what? A repulsion. This is a repulsion because the negative side of the water is also repelling the negative side of the of the ion, that is of the ionic compound, that is the sodium chloride, and that is the chloride, the chloride ion. So that's called a repulsion. And so the sum of these two energies is what constitutes the hydration energy of the sodium chloride. Have you gotten that? Now, so basically what happened when this sum of this energy, that is when the sum of this energy, okay, the two hydration energies are bigger than the hydration energy. So when this particular value, okay, of both the two ions, okay, of both the two separate ions, okay, when the sum of this, okay, is bigger than the lattice energy, okay, than the lattice energy holding the ions of the ionic compounds together, okay, when they are bigger than that, then it means that the salt will dissolve, okay, in water. Then that means the salt will dissolve. And so this is what happens. That is what takes place. So if you want to write the equation for the reaction, I'm going to get the sodium chloride, okay, now salt plus the water. So that is the water, which is a liquid. So there's what we call the interaction energy, okay, taking place. First, what happened? The sodium, the sodium plus, okay, will be attracted by 6 water molecules. This, okay, will be attracted by this, and then the negative ion will also be repelled by 6 water molecules. That, okay, and so 8 separate equations, okay, 8 separate equations. We are going to get what we call this. Okay. Now I have what we call 6 water molecules surrounding this. And then the total charge here is plus, and so I have to put the plus here. And then the chlorine too is the same thing, but here is a repulsion, and so that is why you don't usually see this in books. That's why you don't usually see this in books. You commonly see this one, okay? We commonly see this one, but this is a repulsion, this is an attraction, and this is what? A repulsion. But the sum of the energy, that is the sum of the enthalpy of hydration, okay, of the sodium plus, okay, plus the sum of the enthalpy of hydration of the chlorine minus, okay, the sum of the two energies is what we call the enthalpy of hydration of the sodium chloride, okay, of the sodium chloride. Now when the sum of the individual hydrations of the cation and the anions are bigger than the lattice energy, then the sodium chloride will break, okay. So when we say hydration energy, it is the amount of energy liberated when 1 mole, you see here, you can see from here that I've indicated 1 mole. When 1 mole, okay, of an ion from ionic compound is surrounded by what? Water molecule. So that's under standard conditions, okay. That's what we call standard enthalpy of hydration. And once again, it is the amount of energy liberated when 1 mole of ions of ionic compound is surrounded by a number of water molecules under standard conditions, is what we call standard enthalpy of hydration. And when this hydration energy is bigger than the what? The hydration energy of the and when this hydration energy is bigger than the lattice energy of the ionic compound, then the salt will break. Let me give you another salt so that we can write the examples quickly. So let's say I have magnesium chloride. Okay, I have magnesium chloride. Now in water, what happens? They break. Okay, in water, when you add it to water, remember this is a what? It's a solid. Magnesium chloride is a solid. When you add it to water, the ions will break. Okay, the ions will break, and then finally what happens? We will have what we call the ion of this. Okay, the ion of that, which is H2 plus, be surrounded by what? The 6 water molecules. Be surrounded by the 6 water molecules here. Okay, and that will form what we call the what? The magnesium. We have 6 water molecules here. Okay, we have 6 water molecules here, but the total charge on this side must be equal to the total charge here, so it is plus 2 here. Okay, and then the chloride 2 is the same thing, but we will have 2 chlorides here. We have 2 chlorides here, and I have what? 6 water molecules here. I have 6 water molecules here, and that also will do that, and ultimately we are going to get what? This minus, okay, surrounded by number, but this is a repulsion. I told that this is a repulsion, and which causes a decrease in what? In energy. And so here the total charge must still be what? Must be 2, and of course you balance the equation, and so you are going to put or still put 2 in front of it. You are still going to put 2 in front of it, so we are going to get this one. So but because this normally worry, we stick to only the what? The positive side. Okay, we stick to only the positive side. That this is the equation for the what? For the reaction. 6 water molecules. Okay, 6 water molecules. Okay, and so therefore what happened? There is an attraction between the positive magnesium and then the 6 water molecules, and so we prefer to write this equation. But remember that the sum of the total charge of the reactant must be the same as that of the product, and so I have this over here. So basically that is that when the hydration energy is smaller than the lattice energy, then it means that the substance will not dissolve. Okay, this basically happens when you pour oil in water. Okay, now this time for oil in water, there's no interaction, there's no interaction, and so there's no significant amount of energy that will be produced to break down the molecules of the oil, and so that is what happened. But for ionic compounds, enough hydration energy is produced and to break down the lattice energy. So that is this lecture, and we'll end the lecture here, and in our next episode we'll be looking at the thermochemical laws. We are going to take you through all the laws of the thermochemical reactions. The first law, the law of conservation of energy and mass, and then the law of reversibility, and then we're also going to look at the Hertz law of constant heat summation. Thank you very much.